Galville is a cardeg popper hain kested 3. Use induction to prove that n by n plus 1 over 2 is the sum of the first n natural numbers, the 1 plus 2 plus 3 all the way to n. So proof by induction, what we do, that we show that it's true for n is equal to 1, first of all. Then we assume that it's true when n is equal to k, to prove that it's true for n is equal to k plus 1. So that's our proof by induction. So first of all, we'll let the sum of the first one natural number be p1. So the first term is 1. We want to show that that is equal to 1 by 1 plus 1 over 2, which is equal to 2 over 2, which is equal to 1, so therefore true. Step 2. So we're going to assume that it's true when n is equal to k. So we have pk is equal to 1 plus 2 all the way to k, which using our formula gives us k by k plus 1 over 2. So we're assuming that is true. Third step, we're going to look at p of k plus 1. So when n is equal to k plus 1, we have 1, 2, 3, k plus 1. We want to show that that is equal to k plus 1 by k plus 2 all over 2. So this again is using our formula. So we want to show that the right hand side, so TLC standing for right hand side, is equal to what we have on the left, TLD standing for left hand side. So let's look at the left hand side. We have 1 plus 2 plus 3 all the way to k plus 1. This is equal to the sum of the first k terms, which we know is k by k plus 1 over 2, plus that k plus 1 term. So if we simplify, we have 2 other common denominator, so we get k by k plus 1 on the top, and plus 2 k plus 1, and that's all over 2. And when we simplify, we get k plus 1, because that's common to both terms on the top, so we can factorize. So taking a k plus 1, we're left with k plus 2, and that's all over 2. So this is equal to what we have on the right hand side, so therefore our proof is done. So just a couple of lines explaining what we're doing. Part B asks us to prove that the sum of the first n even numbers is equal to n squared plus n. So we have 2 plus 4 plus 6 all the way to 2n. So we have to show that the sum of the first n numbers is equal to n squared plus n. So we're going to need our formula. S of n is equal to n over 2, 2a plus n minus 1. So we need to identify our first term, which is 2, and the difference between every term, which is 2. And now we just fill into our formula. So n over 2, 2 by a plus n minus 1 multiplied by 2. And we simplify. So we get n over 2 is equal to 4 plus 2n minus 2, which will give us n over 2 by 2 plus 2n, which will give us 2n plus 2n squared over 2, which just simplifies to give us n plus n squared, or n squared plus n. Part C asks us to use the results from A and B to find an expression for the sum of the first n odd numbers in the most simplest form. So first of all, looking at B, which we've just worked with, we know that the sum of n even numbers is equal to n squared plus n. So I'm just going to note that all numbers minus our even numbers is going to give us just the odd numbers. So if we go back to A, we know that the first n natural numbers is equal to n by n plus 1 over 2. So now what we just want to find is the sum of these numbers just going up to 2n, because that's what we looked at in part 2. So using the same formula, instead of n, we're subbing in 2n. So we get 2n and 2n plus 1 all over 2. This is going to give us 4n squared plus 2n over 2, which gives us 2n squared plus n. So that's for our part A for all of our numbers. Part B, for just the even numbers, we know from part B that it's just n squared plus n. So now we want the sum of the first n odd numbers. So we have 2n squared plus n minus n squared plus n. So all numbers minus even numbers will give us the sum of our first n odd numbers. And we're just left with n squared.